So we've seen how we can use the molar mass of an element as a conversion factor to take us from grams to moles or moles to grams. But now we're looking at a compound. Because chances are we've talked about how it's very hard to find elements in their pure form. We have a lot of compounds. Compounds are a lot more common than pure elements. So what do we do if we want to find the number of moles in 22.5 gram sample of dry ice? And dry ice is just solid carbon dioxide, right? So we would go about the same process. We will start with what we're given here, which is 22.5 grams of carbon dioxide. And now we want to go from grams to moles, right? And usually we use the molar mass because the molar mass is given in grams per mole, which is the conversion factor we're looking for. For the element, we just looked it up on the periodic table. But now we have a compound. So we very simply use the formula mass. And we've learned how to calculate the formula mass by adding 12.01 grams per mole of carbon plus 2 times 16.00 grams of oxygen. And this gives us about 44.01 grams per mole for carbon dioxide compound. Okay, so now we're using the formula mass as a conversion factor between grams and moles. So we have 44.1 grams of carbon dioxide for every 1 mole of carbon dioxide. The grams cancel out and we're left with moles. And this gives us about 0.511 moles of carbon dioxide. Don't forget to put your number to the correct number of significant figures, which is 3 here. Don't forget to put your units as well. Okay, go ahead and give this a try, and let's calculate the number of moles of nitrogen dioxide in 1.18 grams of nitrogen dioxide. So we always want to start with what we're given. So 1.18 grams of NO2, and we know that we're going to use the formula mass for NO2, which is our conversion factor. So the formula mass for NO2, when we calculate it, is 46.01 grams per mole. And then we use this conversion factor to figure out the number of moles that we have. So we know that there's 46.01 grams of NO2 per 1 mole of NO2. The grams cancel out and we're left with moles. And this gives us 2.56 times 10 to the negative 2 moles of NO2. Now we want to convert from grams to the number of molecules. Remember that we do this because in the lab, it all comes down to physically what we're actually doing in the lab, right? We measure in grams. We don't measure in moles or number of molecules. So we want to do the same thing. Now we want to know the number of molecules in 22.5 gram sample of dry ice. We always start with what we're given, 22.5 grams of carbon dioxide. We don't have a direct conversion factor from grams to the number of molecules, right? We have grams to moles, and then we have moles to the number of molecules. And from grams to moles, we use the formula mass for carbon dioxide, which is 44.01 grams per 1 mole. But we don't want to stop there because we're being asked for the number of molecules. Notice the difference in the language. Before, for atoms, we were saying the number of atoms for elements. Now we're saying the number of molecules because we have a compound now. So that's the only difference. Otherwise, it's the same exact process, except we use formula mass and we call it the number of molecules as opposed to the number of atoms. So we have for every 1 mole of carbon dioxide, we have 6.022 times 10 to the 23rd molecules. Because a dozen is a dozen, it doesn't matter what it is. A dozen is 12, and 1 mole will always be 6.022 times 10 to the 23rd molecules or atoms, or we can call it particles for short, of anything. So we end up with the grams canceling out, the moles canceling out, and we have the number of molecules left over. And we get an answer of 3.08 times 10 to the 23rd molecules of carbon dioxide or dry ice. Okay, now what is the mass of, this time we're going to go figure out what the mass is of 4.78 times 10 to the 24th nitrogen dioxide molecules. So again, we have to start with what we're given. 4.78 times 10 to the 24th molecules of NO2. Now we can't go from the number of molecules directly to grams. We don't have a conversion factor from that. But we can go from the number of molecules to the number of moles. So we have 6.022 times 10 to the 23rd molecules per 1 mole of NO2. But we don't want to stop there because we want the mass. So we know for every 1 mole of NO2, there's 46.01 grams. We use the formula mass for nitrogen dioxide that we calculated. And this gives us 1.2 365 grams of NO2. And this number makes sense because it makes sense to have 365 grams of something. Go ahead and give this a try. How many H2O or water molecules are in a sample of water with a mass of 3.64 grams? And then replay this video to see if we got the correct answer. If we have 3.64 grams of water, how many molecules we have? We don't have a direct conversion factor from grams to molecules, to the number of molecules, but we can go from grams to moles, and then we can go from moles to number of molecules. Alright, so we're going to use the formula mass for H2O to go from grams to moles. And the formula mass is 18.02 grams per 1 mole of H2O. And then, now we can say, okay, for every 1 mole of H2O,